All right. Well, hi everyone. Welcome. Your mic is muted for now, but we're going to unmute you later to ask questions, or you can ask questions in the Q&A. I'm Karen Hauk of University of California at Berkeley, and this is Space Weather Explorers Week, where space scientists will answer your questions about the sun, its influences in the solar system, and life as a scientist. The website is spaceweather.berkeley.edu. Welcome to our live webinar featuring Dr. Shea Hess-Webber of Stanford University and Dr. Dolon Bhattacharyya of LASP, the Laboratory for Atmospheric and Space Physics. Today's live webinar is called Project Sunway. The sun touches everything, including fashion. This webinar will last about 60 minutes, and you can ask questions throughout. You can ask questions in the Q&A box. If you move your pointer around, it will pop up. You can also ask questions of space scientists via our Discord server, which is linked at the website that I just mentioned, spaceweather.berkeley.edu. Through the end of the week, you can ask questions that will be answered. This webinar is being recorded, and I'm going to introduce our first guest. So Dr. Shea Hess-Webber is a solar physicist at Stanford University. Shea discovered astrophysics because when Shea was 10 years old, her big sister thought that she was actually an alien. And she insisted that a spaceship was going to come take her home to a different planet in a different galaxy. And young Shea wanted to make sure she could go visit her big sis after she left the solar system. So she became determined to study the stars. Later, Shea started an internship at NASA with a solar scientist and realized that the sun is pretty cool, even though it's actually really hot. Shea will share both her love of the sun and her love of her sun-themed clothes, jewelry, hats, and more. Welcome, Shea.
Let me unmute. Hi, everybody. Thanks, Karen, for that introduction. I am Shea, and I will share my screen and talk to you a little bit more about who I am, how I got here, and why I love wearing sun stuff. So let me share my screen and put this in presenter mode, which is here. Okay. So as Karen mentioned, we are talking about fashion because well, first of all, this is the Heliophysics Big Year. And so I wanted to talk a little bit initially about what that is, what that means. You might have talked about that before this week. The Heliophysics Big Year is actually a NASA-driven initiative to try to get scientists and the public to kind of cross each other's paths a little bit more. So every year of this, or every month of this big year, starting from this past October and going through December, so it's 18 months, it's a literal big year. Every month has a theme. And as hopefully you've all been learning this week, the theme for January is the sun touches everything. And so a lot of the programming this week has been in terms of what the sun touches and how it touches everything. But this month, it is now February 1st, this month is Fashion Month. And so this is an opportunity for scientists like me who love the sun so much that I literally wear it on my sleeves to give you all some inspiration in terms of both the science and how to wear the science and how to advertise that you're excited about the science. And that actually does help scientists like me in terms of getting NASA and getting the government to fund some of our research. So the more we can advertise for this sort of thing, the better. So you wearing some things does benefit me as a scientist. If anyone has questions about what the other monthly themes are past this month, then I have information on that, but I would say ask that question in the Q&A. So a little bit about me. Karen kind of gave you the rundown of sort of how or why I'm here. My sister, who is now an adult and no longer, she's still here on planet Earth. She does not think that there is a alien ship coming to take her away anymore. Thank goodness I don't have to go up in a spaceship because I'm afraid of heights. But so how I sort of got to where I am as a scientist, left side of this page is kind of the boring stuff. Where I'm from, around the DC area originally. I graduated high school in 2005. I went to a small liberal arts school in Pennsylvania and majored in physics and minored in math. I got my PhD in computational astrophysics from George Mason in 2016. And from when I graduated high school through when I finished my PhD and actually beyond, when I started into my first postdoc, I was a research assistant at NASA. So I started there as an intern and I worked my way all the way through into a postdoc. And from there, I moved to where I am now at Stanford University, and I am a research scientist here. Now for the more fun stuff. So what I do for my job is actually literally looking through the sun. I'll show you sort of an example of what that looks like in a moment. But this is important because we can only ever see one side of the sun at a time, and the sun rotates. So eventually what's on what we call the far side, the side that we can't see, will rotate around, but the sun is also constantly changing. So we want to know what's starting to happen on the far side of the sun before we can see it, because there may be something there that wasn't there when, like, before it rotated onto the far side. So this helps us do things like predict space weather, things that can eventually impact Earth or spacecraft or astronauts. So it's actually really important. But I do this by looking at waves that are traveling through the inside of the sun. So from the inside of the sun touches everything, the inside of the sun out through predicting what might impact us here at Earth. So I think it's really cool. A couple more fun facts about me. I collect Albert Einstein stuff. I have like a bobblehead and a lot of posters and drawings. I have a copy, an actual like photocopied copy of the letter that he wrote to Roosevelt about not supporting the atomic bomb. I have all sorts of cool things from Albert Einstein. And most importantly of all, I have 3 cats, my fur babies, Culebra, Cosmos, and Umbra. You'll notice the spacey theme throughout here. So yeah, that's a little bit about me. I am human. My sister is human. And now we can sort of talk a little bit more about the sun specifically. So this is a video of the sun, sort of, you think of it unwrapped. So, the Earth is a sphere. If we unwrap the sun or unwrap the Earth into a map, you can see that as a rectangle. That's kind of what we've done here. The gray and sort of yellow green is actual observed data of the sun. That's the sun's magnetic field on the near side that we can see. And the orangey part here is what I do or the data that is produced when I'm looking through the sun. That's what I see. So these dark patches are actually regions that are sensitive to magnetic field. So where this dark region is on the far side of the sun, if you watch that move around, you'll see that a large magnetic region is on the near side. So that's how we track what's happening on the far side of the sun. So that's just a little peek into what I do as a scientist. Now into the more fun stuff, Helio fashion. I'm just going to be talking about, so I kind of sorted things into groups, but I'm going to be talking a little bit about all different sorts of fashion that you can wear. A lot of what I have in my slides are pictures of shirts, but there's a whole plethora of other things and how you can show your love of the sun. So as you all may know, hopefully, we have a total solar eclipse coming up on April 8th. So I thought I'd start out with some eclipse fashion. These are all different shirts that you can get that pertain to an eclipse that are available online. If anyone's interested in any particular one of them, I can send the link or put it in the Q&A. Some of them are kind of fun. If you know the song Total Eclipse of the Heart, back from probably sometime in the 80s, if I am remembering correctly. That's kind of this total eclipse with the heart instead of the sun, kind of fun, but it has the actual like geometry that when the sun and the moon and the earth align for an eclipse, it displays that, but with a heart, which is kind of fun. There's also the progression of happy full, visible sun through to covered up and then kind of a mess on like what just happened to me. Very funny, I think. I'm a big sun nerd though, so take that with a grain of salt. And then again, sort of this is an artist conception, but again, tracking an eclipse through the sky, when it's fully covered, stars come out. Again, a kind of nice representation that you're excited and interested in the eclipse. We can extend it, so it's helio fashion, not just solar fashion. So we can think about things in terms of the sun and its impact on things beyond it, right? The sun touches everything. So here's kind of a fun shirt if you're like a sci-fi nerd like me. Here's the sun with a whole bunch of different planets from different stories around it. So you'll see some Star Trek here. For a long time, we thought there maybe was an extra planet in the solar system, Planet X. So Planet X is represented. If you're a Marvel fan, there's some things. If you're a Dune fan, there's some things. So the sun and, all of this other fun sci-fi around it. Of course, the sun impacts Earth. So go ahead, make my day. The sun literally makes our day. So that's, kind of fun. And then even extending to things that the sun causes. These are things that we're still celebrating in the Heliophysics Big Year, are things like aurorae. The sun produces the aurorae on Earth. So even wearing something like an auroral dress or shirt or jewelry or what have you, is a sign. It's a representation that you're interested in the sun and solar impacts and space weather. So again, some really cool, fun things that you can wear in terms of the solar system itself. I'm particularly excited about solar data on clothes or jewelry or what have you. So you can see here on the left, these two, the skirt and the shirt, that's actually fabric that was created with an image taken from a solar observatory. So this is actually a picture of the sun on clothing. You can maybe see, I'm sharing my screen, but if you can see the picture of me, I'm actually wearing another shirt that has this data on it. I also have a full dress that has the data on it. Very, very fun to be able to like take what I do for my job and actually put it on my clothing. And then on the right here, if you've heard of the solar spectrum, so all different elements, like atoms, molecules, have a certain signature. It's like a fingerprint. And we can use these fingerprints to detect what sorts of materials are in the sun and in the sun's atmosphere. And so if you take a picture of all of these fingerprints combined, you get this picture on the right. And then you can take the picture on the right and, as you can see, put it on clothing. And other things. So I actually have a necklace that I have here with me that has this, what we call the solar spectrum, in the necklace, and you can actually look through it to see the solar spectrum. And it's not just shirts and skirts and dresses and things to like wear clothing wise. You can extend this to pretty much anything. So shoes, backpacks. We were just talking before we started that the mug that I'm drinking coffee out of right now, it's not necessarily fashion, but it's an accessory, right? So I have a bunch of mugs that have suns on them. And that's a way for me to represent and say, look, this is what I'm interested in. You can do earrings. And I have a lot of earrings. So I was going to kind of show you all some of the earrings that I have. So if I stop sharing and you can all see me again. So first of all, here's the shirt that I said that I was wearing. This is the actual data from the solar observatory that we have. So I wore that specifically today to show you all. I also am wearing 4 different kinds of sun earrings that I have. So some of them might be hard to see, and I have ones that are not in my ears that I can show you as well. But what I think is really cool here is actually some of these were handmade for me, both professionally and non-professionally. So for example, these are probably the earrings that I get the most comments on. My sister made these for me out of cardboard and a pom-pom. So you can make this stuff at home. You can spread your love of the sun to other people with things that you make yourself. Some of the things that I showed are on Etsy. You can start an Etsy page if you're inspired by solar or space weather fashion. You can go and sell your your creations and make money on them. One of the other things I think is cool, this was actually made by a professional. But so this is something called tatting, where you basically take thread and tie it into various knots to create a pattern. And I asked this woman at a street fair whether she had any sun earrings, thinking that it would just be a simple sun, and she didn't. So I told her why I was interested. She went and did research and looked up pictures of the sun from the Solar Dynamics Observatory, from some of the data that I'm wearing on my clothes, and she came up with an actual physical representation of the sun that she created using tatting. So you can see there's some sunspots in here. There's some things that look like coronal mass ejections. There's some convection going on in the middle. So you can actually take the science and take the observations and turn that into fashion. And I just think that's super, super cool. A couple other just kind of fun things that I didn't show you. I have socks that have the sun on it. It says "Shine on, you shiny thing." Pretty fun. This is one of my favorite shirts. It says "Burn them all," the sun chasing all of the planets in the solar system. You can create swag for events, like this was for the October eclipse. So this is a hat that we created in order to represent, you know, who was volunteering at an eclipse event. So you can do things like this. I have a bag that has a cool black and white image of the sun, and it actually is a good conversation starter. People think it's the moon or fire, and then it starts a conversation about what it actually is, that it's the sun, what all these features are. So if you're interested in the sun, you can really take all of this, these ideas and run with them and wear them and start conversations about the science, which is pretty cool. I don't know how much time I have. I think that's probably my time, but again, ask questions in the chat and the Q&A. If you want links to anything, I am happy to provide those. And yeah, wear the sun. It's really fun.
Wow. I'm really envious of a lot of those things. The other thing we could do is we could allow people to actually talk if they want. If any of our guests would like to speak or ask questions. I love the data fashion. It's so cool.
I'm actually trying, I'm trying to get more data. I'm actually have been talking to some of the companies that sell these items to provide them with data to put on clothes. So I can give them my data and then I can wear my data, which is really cool.
It would be a great conversation starter at meetings.
Yeah.
Conferences. Let's see. I don't see questions so far, but people, so I'll go on to Dolon, and then people can ask questions at any time, and then we can return to those.
Yeah.
Thank you, Shea.
Of course.
It was really fun. Let me introduce Dolon now. Dr. Dolon Bhattacharyya is here. Welcome. And her primary interest is in studying atmospheric escape from planets. Her research has mostly been focused on studying water escape from Mars. Her NASA mission experiences include being a science team member of the MAVEN IUVS instrument and serving as a project scientist for this mission that we're all involved with, the Carruthers Geocorona Observatory, which supports this Space Weather Explorers Week. She's also a PI and why am I blanking? She's a PI and a co-I on several Hubble Space Telescope programs to study atmospheric escape from solar system objects, specifically Mars and Uranus. At present, she is also involved in projects that characterize atmospheric escape from exoplanets. So welcome, Dolon.
Thank you, Karen. That was a very big and flattering introduction. Let me quickly share my screen and then I will talk about the sun's effect on us. So Shea gave a beautiful introduction of the star that drives all the life on our planet. But I'm here to tell you that not all of it is good. So the sun versus us, it's more like a fight. Also, it's more like how we can only take the good parts of the sun and avoid the bad parts. Let's see. So a little bit about me. I wanted to be an astronaut, and that's how I got into astronomy. And then I realized, oh, wow, everybody around me wants to be an astronaut. And so there's a lot of competition. And probably my chances of getting to space are minuscule, but I can always build a robot that can go to space, which is exciting. And that's how I got into planetary science. I got my PhD from Boston University in 2016, studying water escape from Mars. Mars is the second most studied object in our solar system. And as you all know, there's a lot of rovers and a lot of spacecrafts in orbit around Mars. So my chances of getting an instrument to space was really great. And I was like, yay, go Mars. So when you want to study escape of atmospheres, you mostly look at ultraviolet emissions because UV light cannot go all the way to the surface. So it gives you more of an insight of what the upper atmosphere is doing. And most of the escape happens in the upper atmosphere. So if I want to study escape, I need to use an instrument that can image things in ultraviolet. You cannot do that from the surface. As most of you know, a lot of UV light don't reach the surface of Earth. That's why I use the Hubble Space Telescope, which has UV capabilities to look at and study escape from a lot of objects in our solar system. Now let's go and see why our sun is sometimes a little bit of a troublemaker for us. The plot on the right is a typical solar spectrum, and the wavelength range marked by visible is the one that we can see. The UV part is the one that mostly do not reach the surface. We have the protective ozone layer in our planet that prevents a lot of UV from reaching the surface. The infrared, of course, is large wavelength, and it reaches all the way to the surface. However, the shorter wavelengths like UV are more dangerous and more harmful. Over here, I have shown you that UV can be broken up into several subcategories like UVA, B, and C. UVC is the shortest wavelength, and most of it really don't reach the surface. UVB, some of it reaches the surface, and UVA, a lot of it reaches the surface. What does UVA cause? It causes aging, wrinkling, loss of skin elasticity, and UVB increases risk of skin cancer. So you certainly do not want to be exposed to a lot of UV light. So what sort of protections do we have from our own sun? Nature has given us some protection in the form of melanin, which all of us have in our own skin. So you can literally walk around naked on a sunny beach and have some protection. However, if you keep walking around for hours, that protection might not be enough. So melanin absorbs a lot of UV rays that can cause skin damage, but overexposure happens when melanin is unable to handle the amount of UV that you get exposed to. And that's when you get sunburns. So keep in mind, UV tanning is not great. Another natural protector from our own sun are trees. However, we as humans have been selfishly cutting off a lot of forests. So it's important for us to realize that trees are one of our natural shields against harmful effects from our own star. So we all need to protect trees. Then we come to the fun part, human-made solar protective gear. So once humans realized that our own star is not always emitting good radiation that gives us vitamin D, we decided we need to do something about this. So there's, of course, specific clothing that protect us from the sun, like hats. When you go to a beach, sometimes you feel this tingling feeling on your neck or on your face. Then most of us wish like, oh, I wish we had like a nice wide brimmed hat that could stop this tingling feeling. So hats are one of the most essential ways you can protect your face and your upper body from the sun a little bit. Another important invention is the umbrella. So umbrellas are great at blocking out sunlight and allowing you to move a lot at the same time. So there are like many fashionable umbrellas out there. Some of them I've seen are completely transparent and made of transparent plastic. Those are not very helpful. They might be fashionable, but not very helpful. So you want to stick to umbrellas that are dark colored and not transparent. Of course, there's sunscreen. You can have sunscreen in various flavors and have a nice smell associated with your own sunscreen. Then you have sunglasses. One of the important tools that protect your very vital organ, the eyes, are sunglasses. So sunlight can be very harmful to your eyes, and sunglasses are something that gives you a lot of protection against these harmful rays. Finally, clothes. Clothes are a very effective way to keep you mobile and protect you against the sun. A lot of us love walking and biking, specifically in the mountains. I live in Boulder, and there's the Rocky Mountains nearby, and you want to go hiking sometimes. And because we are 1 mile above the sea, the closer or the higher you are above sea level, the more UV light you get exposed to, because there's lesser atmosphere between you and the sun. So clothing is a great way of minimizing those harmful effects from the sun. Just to give you an idea of how sunglasses work, because our eyes are one of our most important organs, and we need to protect them as much as possible. However, when you go to a sunglass shop, there are many types of sunglasses, and you don't know which ones to buy, basically. So just to give you a brief idea of what the principle behind sunglasses are, you have light coming from the sun, and light are basically electromagnetic waves that have energy moving in many different directions, in fact, all 180-degree directions. What something called a polarizer or a filter does is emit or basically block some of these directional emissions in different ways. So, for example, here in this diagram here, unpolarized light has vibrations in all directions, and then it goes through a polarizing filter that only allows vertical transmission. So any vector that is moving up and down in the vertical direction only gets transmitted. Every other vector gets stopped. So what happens is you are blocking a lot of light from the original source from reaching your eye. And that's how sunglasses basically work. Here is a diagram that shows you what happens. So the sun emits light, and when those light hit any parallel surface, they get polarized. And your glasses can then stop some of those vectors and allow you to have a more comfortable feeling when you're moving around in the sun. Of course, nowadays, when you look at your sunglasses or your choice of sunglasses, they have a lot more advanced coatings that have been specifically developed for preventing different types of harmful UV rays from your sun. So yeah, this is basically a diagram showing how much technology has improved and how much humans have invested in developing sunglasses. Finally, sun protective clothing, very, very important. When you go to a store and you buy SPF creams, there are various levels you would always see, like 30, 50. So clothing also has something similar, but it's called UPF. It's a rating specifically to protect you against the sun and make you realize which clothes are going to offer you more protection versus which ones are going to offer you less. So a UPF rating of 15 offers you the least protection, and UPF rating of 50 plus offers you the maximum protection. Some of the factors that may enhance your clothing rating is the way they are constructed. So like dense construction or of threads, it's going to prevent much of the light from hitting your skin. Darker colors are always great. And there are, of course, many treatments done to clothing that sort of minimize UV rays from penetrating into your body. Fabric types are always helpful. Polyester is the best. Wool and silk, because their weavings are not tight, may allow some amount. Cotton is really bad because cotton is designed for you to walk around in the summer and be cool. So it's designed to allow your body to emit heat. And so the weaving is never tight. So cotton is not great. Some factors that may also reduce UV effectiveness is a wet fabric. So when you are sitting in the beach and you go and take a little bit of a dip and then chill on the beach, your wet clothing is actually giving you a suntan. And when you go back to your room, you realize, wow, a lot of my body is darker. So that's because your wet fabric didn't give you a lot of protection against the sun. Wear and tear can also reduce the effectiveness. And of course, stretching your fabric over time can also reduce effectiveness. So now that we have learned a little bit about sun protective clothing, next time when you buy specific clothing for protection against the sun, keep these factors in mind. For example, now what I'm wearing is a full-sleeved white shirt. It has a tight double weaving, so it gives me better protection, but then it's also white in color, so which reduces somewhat the protection factor. Not only that, radiation is around us everywhere. So you can wear clothes, you can use umbrellas, but there are radiation that will always penetrate no matter what. And so this is showing you how frequently we get exposed to radiation. You go through airport security, you get X-rayed, and that's radiation hitting your body. You get a dental X-ray, radiation hitting your body. You take a flight. When you take a flight, you are above most of the atmosphere, thicker atmosphere of Earth. And so you get exposed to a lot of solar UV radiation, which is kind of bad. So taking frequent flights is not great either. And then astronauts. Astronauts actually have a lifetime. If they get exposed to a certain amount of radiation, they are not allowed to go back into space anymore because it's harmful for them. So there's a radiation limit for astronauts. So the radiation limit also varies because the sun is not a very steady object. It changes its activity with time. There's an 11-year cycle where you see the solar activity peak and then go back down again. So this is what I'm showing here on the left. So there have been years when the solar activity has really peaked, like for example, early 2000s. And then there were years in the middle of, or in the beginning of 1800 when the solar activity was really been minimal and you sometimes had extended winters on our planet. So the solar activity always changes and that affects our own planet. Here's an image of Mars and the Earth. And Mars over here has no shielding against our sun because there is nothing called a magnetic field, a global magnetic field. Our Earth, on the other hand, has a global magnetic field. So it offers some shielding from our own star, but there are still harmful rays that can penetrate into the atmosphere and vaporize a lot of life-giving molecules that exist in our own planet. And that's the focus of my study, like how our own sun can be a life giver, but at the same time can also be harmful to us. That's it. Questions?
I had a question.
Mhm.
In your previous slide, you said that that the dark, or I guess it was the one before that, you were
Mhm.
talking about dark clothing being more protective. And that was interesting to me because I had always heard that light clothing being reflective was more protective. So that was interesting to me.
Yeah, that's something even I have not thought about. But when I think about polar bears, for example, their skin color below all their fur, white fur, is actually dark jet black.
Hmm.
And that's supposed to protect them from sunlight.
Huh. Interesting. I'm waiting to see if we have some questions from the guests. So I gotta check the Q&A, the chat, the email. Just wanted to remind everyone that you can also ask questions on our Discord server. I put the link in the chat. Oh, here's a question from Alex. He says, weren't there recent studies suggesting UVC provided the building blocks for life on Earth?
Yeah. So UV is essential for building blocks because UV creates ozone. Upper atmosphere, most of the UV, the reason is absorbed by oxygen atoms in our planet, and O2 becomes O3. And those O3 atoms actually, or molecules actually absorb UV because they're doing all this, undergoing all these reactions and preventing other forms of UV from reaching the surface. So UV can, like certain bands of UV, wavelength bands of UV can help in being building blocks, but then certain bands of UV or wavelength ranges of UV can also be harmful because they are not being absorbed by the atmosphere, or they are not involved in biochemical reactions. So it depends on the wavelength bands.
Yeah. Great. Well, he added that just to claim that not not all UV is bad.
Yeah, that's right.
Letting someone off the hook.
Yeah.
Any other questions right now? Ah, there you are. Did you say something, Alex?
Oh, no, I was just laughing.
Oh, okay. That's allowed. Okay.
I had I guess, a question, comment, and I want to thank both Dolon and Shea for their excellent presentations. Dolon, you were describing how sunglasses work with their UV coatings. I was reminded of the fact that original sunglass design was really, really bad. And there's been some laws to actually change how they're designed, because original design was for visible light only and did not take UV light into consideration. And so you would have like a neutral density filter that would block visible light, so that when you go out into the sunlight, you're not squinting as much, right? Because it's so bright. But what that does is it causes your pupils to dilate, right? Because you're getting less light in. So your natural reaction then to less light is for your pupils to dilate. And because the glasses did not have UV protection, that meant more UV get into your eyes, right? So
Oh.
it was actually worse. It was more dangerous to wear sunglasses of that type than it would be to just without them, right? And somewhere, I think in either the late 90s or the early 2000s, I'm not sure if laws were passed nationwide or if it was kind of local jurisdictions started to outlaw that design in glasses. And I think, the industry standard now has been in response to that, is to have UV protection on all sunglasses. Although you still, when you go to the store and pick them out, some of them will say whether or not they protect against all of the wavelength bands, right? Some of them only protect against UVA, but not B and C, which of course are the more dangerous ones.
The same for sunscreen. You want broad spectrum. Anything that says broad spectrum protection is key.
Well, thank you so much for talking with us, Shea and Dolon, and thank all the guests for coming. We'll put the recording on our YouTube channel. So please head on over to spaceweather.ssl.berkeley.edu to ask our leading space scientists your questions about the sun and space weather. This occurrence of Space Weather Explorers Week runs through tomorrow, so it's been all week. And the website's always available if you'd like to explore the resources. There's curriculum, there's games, activities, all sorts of good stuff. And we'll be live again April 1st through 5th, helping prepare for the total solar eclipse on April 8th. And this is the last solar eclipse visible in the US until, is it 2044? I believe so. So yeah, come.
Can't remember the exact year, but it's
a long time away.
It's at least 20 years before we get this chance again.
Yeah.
In the US, yeah.
Yes. So please hang out with us. Thanks so much. I'm going to stop the recording and then I'll end the webinar. So thank you, everyone.